Hi guys, so today we're going to have a look at radiation in terms of heat transfer. So our objectives for today are going to be to understand how heat is transferred from one object to another by radiation. So as part of that, we need to be able to identify when transfers are happening by radiation, be able to state how to minimize and maximize radiation transfer, and to be able to explain why all things must absorb and emit radiation. So before we go into how to maximise it and minimise it, we need to first off think about what it actually is. So radiation we might have heard of. It's the thing that turned the Hulk into the Hulk, and it's actually not that scary. It's radiation in this case is looking at infrared radiation. So what we're really talking about when we're looking at heat transfer is this section. Now this section is part of what's called the electromagnetic spectrum. Whoa. What that means is that all of these different types of waves, so you might have heard of radio waves, microwaves, ultraviolet rays, visible light, which we can see down here, X-rays, gamma rays, all of these are types of electromagnetic radiation. Now, when we're looking at heat transfer, the bit that we're actually most interested in is just this section, which is infrared. So there's a few key words that we need to know when we're talking about this radiation. One of them is emit, so we can see that on the screen there. What that means is if something emits radiation, it gives off radiation. Okay? The opposite of that is to absorb, so if something receives or takes in or gets something, it absorbs it. So like a sponge absorbs water, it takes the water into the sponge. And then transfer is the movement of one thing from one place to another place. So these three words are going to be essential to understanding how radiation transfers heat energy. So let's have a look at some examples of this. Here we've got a infrared camera that's pointed at a house. And from this, what it does is it takes in from the sensor, it takes in the infrared radiation, it absorbs it, and it plots it out onto sort of a sensor plot chart like this. And you can see where it gets a lot of infrared radiation, it's coloured it this pink colour. Where it's not received very much infrared radiation, it's coloured it this dark colour. And what that's come from, or this scale has come from when the infrared camera was calibrated. So it was sort of a made-up scale. It doesn't actually look purple, it doesn't actually look blue. But the way that this works is by absorbing that infrared radiation that's coming from that object. And what we can see is that the hotter the object, the more infrared radiation that it emits. So it's giving out more infrared radiation, which then gets absorbed by our thermal imaging or infrared camera. It then colours it in so that we can see it and it looks nice and looks interesting, or we can tell the difference between different areas. But obviously these colours aren't representative of what it actually looks like. All objects in the universe that have a temperature, so almost everything, give out infrared radiation. Okay, only things that would be absolute zero, which is a theoretical temperature, wouldn't give out infrared radiation. Okay, so any object at any temperature will give out radiation. If it's hotter, it gives out more radiation. If it's colder, it means it gives out less radiation. So if we have a look at absorption of radiation first, if we take two surfaces, if we take a matte, rough, dark surface like this one here, and we take a shiny, smooth, light-coloured surface like this one here, we find that matte, rough surfaces are better absorbers of radiation. So if we take some radiation from the outside and shine it onto both of these surfaces, what actually happens is this matte, rough surface absorbs the infrared radiation better. What that means is that less of the infrared radiation gets reflected. So on a shiny, a smooth, a light-coloured surface, like a mirror or like a shiny, smooth piece of metal, will reflect infrared radiation just the same way that it reflects light. Something that's dark, that's rough, that's matte, so not shiny, will absorb radiation. Just like if you look at a black piece of paper, you won't be able to see your reflection in it. So, which metal block is going to heat up faster? It is the black surface, the black block, that's going to heat up faster, and that's because it's going to absorb that radiation, or more of that radiation, rather than reflecting it away from the surface. So, if you lived in a hot country, would you paint your house a light colour or a dark colour? You'd paint it a light colour, assuming that you want your house to be nice and cool, because then it would reflect the radiation from the sun, meaning that your house doesn't absorb so much radiation, meaning that it's cooler. Now, if we have a think about emission of radiation, this is where a lot of people get mixed up actually, because a lot of people accept that a dark surface absorbs radiation well, and so actually to emit it, it must be the opposite. Well, actually, that's not true. It's the same. Okay, so matte, rough, dark surfaces are also the best emitters of radiation. Okay, they're better than shiny, smooth, light surfaces. Okay, so just like in that previous question that we were looking at, or that previous example of absorption, it's the matte, rough, dark surfaces that are better at both absorbing and emitting radiation. Now, that's partly to do with the surface of that material. So if it's dark, if it's rough and matte, then on a microscopic level, if it's rough, we see that the surface would look something like this. And this surface, if it's smooth and shiny, then it would be something like this. Now, actually what this means is that here there's more surface area. If we stretched all of this out, it would go for longer than this side. There'd be more surface area with which infrared radiation can be emitted. And it's kind of the same for when we're looking at absorption. When the radiation comes in, it gets hit into these little folds, into these little rough patches, bounce around a few times and get more of it absorbed. So it's the matte, rough surface, this is the key thing, is the best emitter of radiation, but also the best absorber, as we saw in the previous set of questions. So if we have a think about a couple of questions with this then. Which of these soups is going to lose the heat quickest? Hopefully you said the black canned soup, so the soup on the right, this one here, that will lose its heat the fastest because it will emit the most infrared radiation, which is then going to transfer that heat energy to another object somewhere else when it gets absorbed again. But the hot soup's temperature, this hot soup on the right, its temperature will go down the fastest because it's able to emit more infrared radiation. Okay, final question. If you had a food home delivery business, would you deliver the food in a dark coloured container or aluminium foil? You'd do it, if it's hot food, in a aluminium foil container, and the reason for that is the opposite of this question that we first looked at, is that you don't want it to emit the infrared radiation, you want the food to remain hot. Okay, so you'd use the foil side, which then means that it doesn't emit so much radiation, so it will stay hotter for longer. Okay, so hopefully if we go back just to check out what our objectives were right at the start, we should be able to identify when transfers are happening. Okay, so transfers are happening whenever an object has a temperature, it is going to be emitting some radiation. How do we maximize and how do we minimize it? Mainly it's to do with the surface, it's to do with the colour of the material on the outside, or with how smooth or rough it is. And why all things must both absorb and emit, again that links back to that idea that anything with the temperature is going to emit radiation. It's just how rough or how smooth or what colour it is that's going to determine how effective it is at giving out that radiation or absorbing it. Okay, so hopefully that's a summary on radiation for you. You'll get to have a go at some practicals looking at this in this next lesson. Okay, thank you.